Looking a little more specifically at function notation, focusing just on the idea of function notation. If we have a function f of t equals 2t squared minus 4t plus 7, and if we want to evaluate the expression f of 2, well, you see that we've replaced t by 2 here. Now if we're to maintain consistency, we're going to replace all the t's by 2. So that f of 2 is going to be 2 times 2 squared, because we have t squared up here and we're substituting in 2 for t. There's an old song by that name, wasn't there? Okay, so if we substitute 2 for t here, I guess it was t for 2, wasn't it? We get 4 times 2 and plus 7. We evaluate that, we get 7. If we write f of 5, we mean what we get when we plug 5 into this expression, because 5 is replacing t. So 5 replaces t throughout, and we evaluate this, we get 37. Similarly, if we say f of negative 3, t has been replaced by negative 3, so we replace all t's by negative 3, and this is what we get. Now what about this expression here, f of aardvark? Now I have no idea why anybody would want to write this, except perhaps to illustrate a point, which is why I did. But f of aardvark is hard to interpret, but it's not hard to do. Aardvark has replaced t, so that all the t's are going to be replaced by aardvark. Now I don't know what an aardvark squared is either. 4 times an aardvark might be interpreted as a loss of 4 aardvarks, negative 4 times aardvark. But this expression really is nonsense, but it still illustrates the point that whatever we put here, we're going to substitute for t. Function notation is very important. We can talk about functions in ways that we could not otherwise talk about them. At least, we can talk about them much more efficiently. We could say that when we want to graph a function f of t, one thing that we always want to do is find its zeros if possible. We want to find where the function is 0, because that tells us where the graph of the function is going to go through the t-axis. We're always going to want to find the y-intercept. Now how do we find the y-intercept of a function? The y-intercept occurs where t equals 0. So we're going to say it occurs where y equals f of 0, putting in the 0 for t. Now if it's a quadratic function, of course, we'd also find the vertex, the points 1 unit right and left. We would go through a lot of details for whichever function it is we're trying to graph. When we find the zeros, we're really asking the question, when does f of t equal 0? Remember, f of t is an expression or a rule that tells us how to find the value of the function when we have the value of t. So when does f of t equal 0? This is a question that gives us the zeros. If it's a quadratic, of course, we would have this. We'd have a quadratic equation. We'd follow the usual procedures to evaluate those zeros.